Welcome students to another lecture on real analysis, in which we shall show that the function f of x equal to sine square of x is uniformly continuous on R. First we discuss the definition of uniform continuity. A function f of x is said to be uniformly continuous on an interval I if for all xy belongs to this interval I. X minus y mod, if x minus y mod is less than delta, then f of x minus f of y mod is less than epsilon. So for a function to be uniformly continuous on an interval, this definition must be satisfied. Now we try to apply this definition to this function, which is f of x equal to sine square of x. Now in this case we have function f of x equal to sine square of x. Now we have to prove that this function is continuous, uniformly continuous on R. For this we take 2 points from R. Let x1, x2 belongs to R such that x1 minus x2 mod is less than delta, and this is our equation number 1. Now we try to establish a relation between delta and epsilon. For this we take function now f of x1 minus f of x2 whole mod is equal to sine square x1 minus sine square x2 whole mod. Now we can write it as this is equal to sine x1 minus sine x2 into sine x1 plus sine x2 mod. Now by using the property of modulus function, we can write it as property of mod. We can write it as sine x1 minus sine x2 mod and to sine x1 plus sine x2 mod. Now we have two relations for sine x1 and sine x2. By using these two relations, we can write it as sine x1 minus sine x2 can be written as 2 times sine x1 minus x2 by 2 and to cos x1 plus x2 by 2 mod. Similarly, sine x1 plus sine x2 can be written as 2 times sine x1 plus x2 by 2 and to cos x1 minus x2 upon 2. Now students, we have different relations for sine and cos. First, I take modulus on each term. By using the property of modulus function, we can write it as mod of 2 is equal to 2. 2 is a constant, so it can be written as 2 times sine x1 minus x2 by 2 mod cos x1 plus x2 upon 2 mod, and I write it as 2 into 2 is equal to 4, equal to 4 times this 2 and 2 equal to 4 sine x1 plus x2 by 2 and to cos x1 minus x2 upon 2 mod. Since the reason is, as we know that mod of AB is equal to mod of A and to mod of B by using this property of modulus function. Now students, as we need a relation between delta and epsilon, and we know that x1 minus x2 mod is less than delta. Our task is to establish a relation between delta and epsilon. Now we need a function in which x1 minus x2 appears as a factor. From here, we need a relation in which x1 minus x2 appears as a factor. Now we have different relations for sine and cos. As we know that the relations are, as we know that sine x mod is less than or equal to 1. Similarly, we have a relation that sine x mod is less than or equal to x. Also, we have cos x mod is less than or equal to 1. Now, whenever we deal with trigonometric functions, we use these identities according to the situation. As situation demands that we need a relation for in which x1 minus x2 appears as a factor. So in this case, I write it as sine x mod is less than or equal to x. So in this case, we have 4 times this is less than or equal to sine x mod is less than or equal to x. Here the argument is x1 minus x2. So by using the property, we can write it as this is less than or equal to x1 minus x2 upon 2. The reason is this inequality. Sine x mod is less than or equal to x. Similarly, now we use these two relations as cos x mod is less than or equal to 1. So we can write it as 1. Sine x mod is also less than or equal to 1, and cos x mod is less than or equal to 1. Now we needed a function in which x1 minus x2 appears as a factor. So clearly we can write it as this is equal to 2 times x1 minus x2 mod. Now we need a relation between delta and epsilon. So now we take, let epsilon is equal to first I use equation 1. In equation 1 we have x1 minus x2 mod is less than delta. X1 minus x2 mod is less than delta. Now by using this equation, we can write it as this is less than 2 times delta. The reason is equation 1 in which x1 minus x2 mod is less than delta. Now we need a relation between delta and epsilon. Now we choose let epsilon is equal to 2 delta. Then delta is equal to epsilon upon 2. Now by using this relation, this value of delta, we can write it as on the left hand side we have f of x1 minus f of x2, which is sine square x1 minus sine square x2 mod. Now we can write it as, which implies sine square x1 minus sine square x2 whole mod. This is less than 2 times, as value of delta is epsilon by 2, epsilon by 2. So which gives us sine square x1 minus sine square x2 mod is less than epsilon. Now for any epsilon greater than 0, we have a delta greater than 0 such that whenever x1 minus x2 mod is less than delta, then sine square x1 minus sine square x2 is less than epsilon. Now we can write it as, which implies as x1 and x2 are arbitrary point of a real numbers or any two real numbers. Now this result holds for all real numbers x1 and x2, which implies sine square x is uniformly continuous, on R. Students, I hope you like this video lecture. Don't forget to subscribe my YouTube channel. Thank you very much for watching this video.